Hi there. So we are going to make a keyword cipher now in Python. I'm going to scavenge a little bit of code from the Trithemius cipher, which I made in another video. If you're curious about the few things that are already on the page, feel free to look back at the Trithemius video where I explain these parts in more detail. Before we code, let's talk about what the keyword cipher is. So, similar to the Trithemius cipher, you have the regular alphabet march along, but in the beginning of the alphabet, you have a word that has no repeated letters. So, something along the lines of monkey or love, or don't really know why these are my examples, but if the alphabet started with monkey, then starting after monkey, M-O-N-K-E-Y, the alphabet would proceed with A, B, C, D. But monkey has the letter E in it, so instead of having E follow D, you would skip the E. And you do this for all the letters in the keyword. So you remove the letter from the rest of the alphabet that went into the keyword, but other than that, the alphabet continues to just march on in the way it always does. So we're going to ask the user to enter the keyword. Let's say keyword, lowercase, no symbols, and no repeat letters. Right. I think this next one is also good. Okay. So first, the keyword and the plain message need to be stripped. So keyword alphabet equals list and then keyword strip. Right. And that's just to parse out the individual letters, the characters, and make them elements of the list. So the method I'm going to use may not be the most efficient, but I'm going to create a list of indices that I want to remove from the plain alphabet before putting the coded alphabet together. So initialize a list, so index remove equals empty list, and go ahead and make the keyword alphabet. Use a for loop for X in alphabet. Now remember, this is a character. We're going through and we're saying literally for A, B, C, D, so for a character in the alphabet, and for char, which is again going to be a character in the keyword alphabet. So if the two characters are equivalent, then we want to make a note of what index to remove from the alphabet. So if char is equivalent to X, then index remove dot append. We're going to say alphabet, and then we're going to find the index, right? Because we don't have a number here, we only have these individual letters. So we're going to need to find the index with the index function. So index of X, there you go. So this will return a number right here. If, for example, it was the character B that happened to be both in the keyword and in the alphabet, then the alphabet dot index for B would be 1 because computers start counting from 0. So 0, 1. We're going to need to cycle through the list of indices that we've just created and remove them from the alphabet. I'm going to initialize X equals 0, and then for each element of index remove, we're going to dot remove alphabet. And then this is a little tricky. It's going to be I minus X. And then follow that up with X equals X plus 1. Okay, so why did I do this? If I go for each element of index remove, so let's say my index remove list has the numbers 5, 7, and 9 in it. If I remove the index 5 from the alphabet, then the alphabet list gets shorter. And what was once index 7 has now shifted by 1. So I need to adjust my index 7 to now be index 6. To avoid removing elements of the alphabet that you don't want to remove and leaving others behind, use this updating X value. moving on to create the keyword alphabet for real. So for char in alphabet, keyword alphabet dot append char. Now we're ready to encode the message. So encode message. The list of the plain message, which was the input, is stripped. Coded index list is going to be an empty list for now, and then the coded message is an empty string. So first, if y is equivalent to a spacebar, then append a spacebar. Move on to creating a list of coded indices. So this is going to be our else. And now we're going to do a loop. We want to go through all of the letters in the alphabet. So for I in range 26, if keyword alphabet for that index is equivalent to y, then we're going to append that index. So coded index list dot append that index. Reconstruct the indices into the coded message now. So here's another for loop. I think it's our last one, so bear with me. For x in range length of the coded index list, if coded index list at that index x is equivalent to a space, then we're just going to add a space, and coded message equals coded message plus a space. If it's not equal to a space, coded message is equal to coded message plus the alphabet of the coded index list x. Let's get our coded message results. Print the coded message, and then let's indulge the users again. So for those who are curious, if you want to see the alphabet, then it's a yes or no. And if see alphabets is equivalent to a yes, then let's just say print coded index list and print the keyword alphabet. Okay, all right, let's see if I've done things correctly this time. Oh no, I've done something wrong. Okay. Oh, of course. So Python determines whether something's within loops and if statements based off of whether or not the code is indented into the loop or the if statement. So let's fix that. I really seem to be liking this word monkey, so let's go with monkey. What message should I say now? I like blue skies. Oh no, I've done something else wrong. Let's see. Well, it just goes to show that everyone makes mistakes. So I did two things wrong. First, I did not put keyword alphabet in there. A simple slip up, but I was indexing the wrong alphabet. So that's a problem. And second of all, I needed to make the coded index list earlier before I altered the alphabet. So I took what was once here, this whole section about plain list, stripping the message, and creating the code, and brought it up here. So before we even made the keyword alphabet. And that's because we altered our alphabet. So our alphabet, as you remember, we actually ended up removing elements from the plain alphabet. So before we do that, we need to collect the indices of the plain message. So basically, I just copied and pasted these things and put them up higher. So let's give this another chance. Let's say monkey again, and I like blue skies. All right, here we go. Okay, this is good. So now let's see our alphabets just to check things. We've got C, so this would be I. So A, B, C, D, E, F, G, H, I. Perfect, awesome. And then this is another like, so I became C again. So L, let's see, Hijkl. So that's G. Perfect. Okay. So it looks like things are working out now. But it's good to make mistakes because then you kind of have to go back and think about what on earth you were trying to code again. So I hope that you have fun with this cipher and have fun with Python because it's really fun to be able to do these sorts of things. It would take quite a long time if you were to write any sort of message with pencil and paper, and you'd have to rethink every letter of the alphabet. So good luck and have fun coding.